Okay guys, we are going to make your second quarter test 1 and 2 cheat sheet. So top left hand corner, we are going to put the first derivative test. Okay, then we're going to do the second derivative test. Okay, so let's just we're going to write out the steps for how you do it. First thing, I'm going to tell you what the purpose of each test is. So a first derivative test tells you increasing and decreasing intervals, and it also tells you relative extrema. And then remember, as we've talked about, an extrema is a min or a max. Okay? So a first derivative test tells you increasing and decreasing intervals, and it tells you a relative min and max values. So step number 1, you're going to take the derivative. Okay, remember that's f prime of x. Then step number 2, you're going to find your critical numbers by setting f prime of x equal to 0 or undefined. And then remember, all that means is that when you're setting the derivative equal to being 0 or undefined, you're acknowledging that critical numbers can come from the top or the bottom. Okay, number 3, you're going to do an interval test. Okay, so that would be your number line. Basically, you're looking for sign changes. Test for sign of f prime on each sub-interval. Okay, then I'm also going to put a little note here that remember, double roots will have no sign change. Okay, double roots have no sign change. Okay, then remember, you are going to identify your extrema at that point. Remember that a relative extrema is also sometimes called a local extrema. And remember the differences for a relative min, f prime changes negative to plus, and for a relative max, f prime changes plus to minus. Okay? The only other thing I'm going to add to that is that make sure that you also understand that an absolute extrema and then I'm going to put in parentheses, that's the same as global. For absolute or global extrema, you do a candidate's chart. With your critical numbers that you would have found and your endpoints. And you're comparing the y values, which means that you're plugging back into the original. So if here was my chart, x, f of x, that's the original, and then remember, I'm going to put my endpoints and my critical numbers. And then whichever of those y values is the biggest, that's my absolute max. Whatever the y values is the smallest, that's your absolute min. Okay? Pause the video if you need to, but I'm going to keep going. Now we're going to do the steps for the second derivative test. Second derivative test. So coming back up here to the top, again, pause it if you need to. Okay, remember that a second derivative test tells concave up and concave down intervals. Okay, remember that it also tells you points of inflection. Okay, that is the job of the second derivative test. So remember, for your steps, step number 1, you are going to take the second derivative. And remember, that's called f double prime of x. After you take the second derivative, okay, you are going to set it equal to 0 or undefined. And remember that we call those your possible points of inflection. Okay, then from there you're going to make an interval test. And remember that you're testing for the sign of f double prime. Okay, and you're doing that on each subinterval just like we did before. Okay, after you do your interval test, at that point you should be able to identify points of inflection. And that would be where f double prime of x changes sign. Okay, so remember that if it's something like a double root, that would not count as a point of inflection because you actually don't have a change in concavity. Okay? The only other thing that I would ask you just to remember is that remember that the second derivative test tells you if f prime is increasing or decreasing. So that's also important, but I'm not going to put it on your cheat sheet. Okay, when you're ready, turn over to the back page, please. Back side. Okay, so top left-hand corner, we are going to put position. Okay, remember that position is generally given by x of t, s of t, or y of t. Okay, it also can sometimes be other letters, but those are the usual ones. Okay, and then this tells you directional location from the origin. So it tells you if your particle is beginning above the x-axis, below, or I'm sorry, above the origin, below the origin, to the left, to the right, whatever. Okay, velocity. Okay, velocity tells the direction the particle or the object or whatever it is traveling. Okay, so remember that when velocity is positive, then particle is traveling up or to the right. Okay, because typically those are your conventionally positive directions. Okay, versus obviously if velocity is negative, then particle is traveling down or to the left. Okay, and I'm just going to put particle is traveling down or to the left. So that is something you should know. Then the last thing I'm going to add under this is remember speed's relationship. Okay, speed is the absolute value of velocity. So whatever your velocity is at a given value, your speed is just going to be that number's absolute value or positive. Okay? Last one we're going to add up here is acceleration. Okay, remember acceleration is typically a of t, and it's the derivative of velocity. Let me add up here. Okay, velocity is the derivative of position. Acceleration is the derivative of velocity. So I would go ahead and write that up there as well. Okay, and then remember that acceleration's job is it tells you if velocity is increasing or decreasing. And remember, the reason that is that acceleration is velocity's derivative, which means it's the slope of velocity. Okay? Now, the last thing that I'm going to add down here is for speed. Remember that acceleration by itself tells you velocity increasing or decreasing. But speed increasing or decreasing is more complicated. Speed is increasing when v of t and a of t have the same sign, versus speed is decreasing when v of t and a of t have opposite signs. Okay. And then the last thing that I'm going to add, kind of, that I just thought of, is the towards or away question. Okay, remember you're traveling towards or away from the origin. Okay, that requires you to know the position and the velocity. So speed increasing or decreasing, you need velocity and acceleration. But for traveling towards or away from the origin, you need position and velocity. Okay. So position tells you what side it's on. And then velocity tells you the direction traveled. Okay? Alright, the very last thing that I'm going to put down here is going to be a graph of f prime. Okay, and we don't have a ton of space to do this because we wrote a lot of notes here. But for your graph of f prime, okay, remember that f of x is increasing when f prime of x is greater than 0 or above the x-axis. Okay, so this is stuff that you should already know. Now, think about, if we're talking about position, velocity, and acceleration, okay, then the particle is, whenever f of x is increasing, that's when your particle would be traveling to the right. So we'd be looking at this whole thing here, and then this whole thing here. Okay, so let's go ahead and give this some letters. So we'll say this is A, B, C, and then we'll say that's infinity. So that would be on A to B, union C to infinity. Okay, now when would my particle f of x be decreasing? Well, it would be when it's below. Okay, second question would be f prime. Remember that f of x is concave down, or actually we'll do concave up, when f double prime is greater than 0. And remember, that's when the slope of f prime is greater than 0. So if I'm looking for a positive slope on this same thing, then I would say I have a positive slope from negative infinity until here. We'll call this value, let's say, d. And then I have a negative slope on this interval here. And then we'll call this e. I have a positive slope here. So I would say that would be on negative infinity till d, union e till infinity. Okay? So remember, your graph is going to be increasing when your derivative graph is above the x-axis. Your graph would have been concave up when f double prime, which is the slope of f prime, is positive. Okay? So now let's put this in the context of position, velocity, and acceleration. If this was a velocity graph, okay, then f increasing would be when my particle is traveling to the left, or to the right. Okay, and I'd still be looking for that interval where I'm above the x-axis. Okay, then when f is concave up, that would mean that velocity is increasing. and you'd be looking at the slope of the graph of v of t. Okay? So just kind of some things to think about. You have your cheat sheet. You get to use it on your test. If you decide not to make one, boo, bad job. Don't do it. Okay? You can do it. Bye.